Z transforms and some basic together with the definition of Z transforms, we have stated some basic standard transformations. The most important rule was the damping rule, and using the damping rule, we have proved some more standard transformations. Now, today we shall continue with the topics again, that is Z transform, and with the help of this topic, we are going to apply the basic definition or some standard transformations for finding out the solutions of the questions. So let us find out. The question is find the Z transform of cos of n pi by 2 plus pi by 4. This is we are going to find. We have to find out the Z transform of cos of n pi by 2 plus pi by 4. And what does it mean? You need to find out the Z transform of this function. So the Z transform of, we shall apply the formula of cos of a plus b, and it will be cos n pi by 2 cos pi by 4, and that will be minus sine n pi by 2 and sine pi by 4. And the Z transformation of cos pi by 4, that is, the value is 1 over square root 2 into cos of n pi by 4 minus the value of sine pi by 4 is again the same, 1 over square root 2 sine n pi by 2. And we also know that by linear property the constant term can be taken out. So 1 by square root 2 is out here, and we can write down, and that is 1 by square root 2 into Z transform of cos n pi by 4. And similarly for the second term, minus 1 by square root 2 Z transform of sine n pi by 2. N pi by 2 is there. This value should be 2, not 4. This one, there should be 2 here, this should be 2 here. So please rectify. This is 2, this is 2. Now you can apply the formulas straight away, and the formula was Z transform of cos of n into theta. This formula was computed, and similarly Z transform of sine of n theta. This was computed in the previous class, and the formula for cos n, Z transform of cos n theta was Z into Z minus cos of theta, and it is divisible by Z square minus 2Z cos of theta plus 1. This was your formula, and similarly the formula for Z transform of sine n theta was Z sine theta, and what is this is theta, not theta by 2, which is Z sine theta, and denominator is same as we have written earlier, Z square minus 2Z cos of theta plus 1. This is the formula, and you can apply the formula now. Just see this formula, Z transform of cos and theta. And what is theta here? This is pi by 2. So you can substitute the value by using the formula Z minus cos of pi by 2 and divide by, that is Z square minus 2Z into cos of pi by 2 plus 1. The next one is minus 1 by square root 2, and use the formula for Z transform of sine n theta. The second formula is applicable, Z sine pi by 2 z square minus 2z and cos of pi by 2 plus 1. Now we shall use the values, and the values are, we know that cos pi by 2 is 0. Well, this is cos 90. Cos 90, the value is always 0. So this will be 1 by square root 2, and in the numerator there will be z square now, and in the denominator there will be z square plus 1, because this cos pi by 2 also give 0 value, and 1 by square root 2 can be taken common. Sin pi by 2 is again 1, because sin 90 is 1 always. So denominator is z square plus 1. So ultimately you can take the LCM, so it can be solved like this. In the numerator there will be z square minus z. No further calculations are required. So this is the required z transform of the given question. So we can do one more question, that is find out the z transform of, that is cos hyperbolic. The question is in terms of a hyperbolic function. Cos hyperbolic n pi by 2 plus theta. This is the question now, and we can apply the formula of cos hyperbolic theta. If you remember, the formula for cos hyperbolic theta is equal to e raised to power theta plus e raised to power minus theta over 2. This is the formula. So you can apply the formula e raised to power n pi by 2 plus theta plus e raised to power minus n pi by 2 plus theta and divide by 2 can be written here. And because this is the z transform of, it can be written e raised to power n pi by 2 into e raised to power theta, and the next one is e raised to power minus n pi by 2 and e raised to power minus theta and divide by 2. This is just a simple step of algebra. And what is this? 1 by 2 can be written out by linear property, and inside is e raised to power theta is a constant, because we don't know the value of e raised to power theta. So e raised to power theta can be written here into z transform of e raised to power n pi by 2. And similarly, e raised to power minus theta is a constant. Its z transform cannot be computed, because we don't know the value of theta and we don't have n here. So it can be written out as it is into the z transform of e raised to power minus n pi by 2. So we shall apply the damping rule together with the formula for computing the z transform of this function and z transform of this function. Only difference is there is a positive sign and there is a negative sign. So remember, we know that the z transform of e raised to power n, this was the formula. This is the basic standard z transformation, that is z over z minus e. Therefore, we can find out the z transformation of e raised to power n pi by 2, and that can be used over here. And what is that? That is z over z minus e raised to power pi by 2. By using this formula, we can write down the standard z. transformation of this function. And similarly, we can find out the z transformation of e raised to power negative n pi by 2. That should be z over z minus e raised to power minus pi by 2. So these are the formulas. You can use the values here. That is 1 by 2 e raised to power theta into. Its formula is z over z minus e raised to power pi by 2, and e raised to power minus theta into z over z minus e raised to power minus pi by 2. That is 1 by 2, and you can take LCM, and it can be written z minus e raised to power pi by 2 and z minus e raised to power minus pi by 2. We are going to take LCM over here just to simplify the step, just to simplify the expression. And what it will be, that will be z e raised to power theta into z minus e raised to power minus pi by 2 can be written here. And in the next step, that will be z e raised to power minus of theta and into z into z minus e raised to power pi by 2. This is by taking the LCM. Now you just try to make this expression more simple. And for this we have to solve it more. In the denominator, that is z square minus z is common, e raised to power pi by 2 and plus e raised to power minus pi by 2, and that will be plus 1 in the denominator. And in the numerator, z can be z square can be taken common. That will be e raised to power theta plus e raised to power minus theta. And in the next step, you can write on minus of z exponential term is there. You just see e raised to power theta and e raised to power minus pi by 2. And this is the negative term, and this is the positive term we have, and this will also be another negative term. So this term can be written earlier. So by simplifying it, we can write on e raised to power pi by 2 minus of theta plus e raised to power minus of pi by 2 minus theta. We just trying to return the term in more simple form. And this is the expression now. Now, for simplifying it more, we are going to use this formula again. This formula is going to be very important for simplifying the expression. Just see the formula. This is the formula for cos hyperbolic function. So we shall use the formula here. And by the formula, it can be 1 by 2. This should be 2z square cos hyperbolic theta, and this will be minus z cos hyperbolic pi by 2 minus theta, and in the denominator, that will be z square minus 2z cos hyperbolic pi by 2, because the angle is pi by 2 there, plus 1. No, this is the formula. Here should be 2 again, because we are using the formula. That will be 2 times cos hyperbolic of that. So in the numerator, 2 can be taken common, this 2 and this 2, and that will be cancelled with this one. So you can cancel and write down the remaining terms. That is the z square cos hyperbolic theta minus z cos hyperbolic pi by 2 minus theta, and divided by z square minus 2z cos hyperbolic pi by 2 plus 1. You can, if you want to do it more, if you want to more explain it more, you can do more steps. Otherwise, you can leave the question here. This is your required z transformation of the given function. So this is very important to find out the z transforms of a question. Now, related to the binomial coefficients, we also have a question to find out the z transformation. Z transformation of NCP. This is the term which comes in as a binomial coefficient. Here P is a line between 0 and n. Ultimately, we can say that there will be 1 plus x raised to power n. So we have to explain that will be NC0 plus NC1x plus NC2x square plus so on. There will be somewhat a term NCP x raised to power will be there, and that will be x raised to power p and so on. And the last term will be that will be NCN x raised to power 0, x raised to power n, not 0, this should be n. So this is the binomial term. In that binomial term, we have this coefficient of the term. And we have to find out its z transform. And by the formula of z transform, that is NCP, that will be z raised to power minus p. And what will be p? P is varying from 0 to n. This is the summation, and you can write on 1 plus NC1 into Z inverse plus NC2 into Z power minus 2 plus NCN Z raised to power minus n. By using the values, we are writing the terms. That will be 1 plus Z inverse whole raised to power n. The formula will. This is the formula for positive coefficient n. But now P is for the negative because we are in Z transform. We are using the Z transformation. So in Z transformation we have the formula. So this will come out to be like this. Further, if you want to write, it will be 1 over 1 plus 1 over Z raised to power n. So this is a function of Z. So you can write down this is a function of Z variable. So this is the Z transformation. So any type of question of binomial coefficient may also come to find out the Z transformation. One more question we have related to the binomial coefficient, that is find out the Z transformation of n plus p c n. This is the question, and by using the formula, that is summation p is 0 to n, that is n plus p cp, and that will be z raised to power minus p. By using the formula of z transformation, now you can expand the summation, that will be n plus 1 c1 z inverse plus n plus 2 c2 z raised to power minus 2, and so on up to infinity. Now the terms further can be solved here, that will be 1 plus n plus 1 C1 is n plus 1 into Z inverse. N plus 2 C2 means that is n plus 2 into n plus 1 upon 2 factorial, and that will be Z power minus 2. If we write one more term, that will be n plus 3. Even that can be written n plus 3, n plus 2, n plus 1 divided by 3 factorial into Z raised to the power minus 2. So the terms can be solved now, and it can be written like this. That will be 1 plus just to have the arrangement of the terms, because we have to write down the expression in simpler form like this one. So for this, we have to adjust the signs, positive signs with the negative sign or negative signs with the positive sign. So if I write down like this, I have to adjust the negative sign. So what will I do? I'll write down like this. I am adjusting the negative sign here. Similarly, the negative sign is adjustable here also, that is Z raised to power minus 2, and similarly we can adjust in the third term also. So this is a simple adjustment of the signs, that will be minus Z raised to power minus 3 plus so on. Now we are doing so because this become the formula. This term can be written more simpler, because we have to write down the binomial term, and it can be written like this. That will be minus Z inverse whole raised to power 3, and this will also be written like this term. This term can be written minus Z raised to power minus 1 whole power 2. So what it will be? That will be 1 minus Z inverse whole raised to power minus of n minus 1. Now its binomial will be this. So this is the way to write down in more simpler manner. 1 minus 1 over Z whole raised to power minus n plus 2. So this is the Z transformation of this binomial coefficient. They can ask for any coefficient, so you should be well prepared and well practiced while doing the questions. Let us move further. As in the Laplace transformation, we have done questions related to unit step function and unit impulse function. Here, the question may come also for finding out the Z transformation of unit step function, that is 0 and 1, n less than 0 and n greater than or equal to 0. This is the unit step function. And the question for unit impulse function, that is also a delta. And what will be that? That will be a delta, and the value will be either 1 or 0. The value 1 will be for n equal to 0, and n not equal to 0, the value is 0. Now we need to find out its standard Z transformations. So let us do the Z transformation of un, that is unit step function. By definition, that is n 0 to infinity u of n Z raised to power minus n. This is the formula. So that will be first for 0 value, that will be u0 Z raised to power minus 0 plus u1 z raised to power minus 1 plus u2 z raised to power minus 2 plus so on. So what will be that? What is the u0? Mean the value for n equal to 0. The value of u0 will be 1 from this. So z raised to power minus 0 is also 1. U of 1. The value is again that is 1 by using this for n greater than or equal to 0. All values are 1. So that will be 1 plus z inverse plus z raised to power minus 2 plus so on. So it can be written as 1 minus z inverse 4 inverse by using the binomial. So 1 over 1 minus z inverse can be written, and if you want to solve it further, it will be z over z minus 1. So this is the standard z transformation of a unit step function. You must remember this. The question may come for 2 marks also. Similarly, we can find out the z transformation of Dirac delta. That is the unit impulse function. That is delta n. That is to power minus n, and is 0 to infinity. That is delta 0. That is z raised to power minus 0. Delta of 1. Z raised to power minus 1. Delta of 2. Z raised to power minus 2, and so on. What is the delta of 0? The value is 1. You just see the value from this delta of 0 is 1, and other values are all 0. So all values will be 0 mean that will be 0 plus 0 plus so on. Ultimately the value is 1. So this is also the standard Z transformation of unit impulse function. So Z transformation of unit impulse function delta n comes out to be 1. This is also very important. So you must be well prepared or well aware by these rules. Uh, we also have a property or a rule which we should know, that shifting un to the right. Uh, the heading is shifting un to the right. Un is a function of n, and first we do shifting to the right, and then we shall do shifting to the left. And what is the statement? If get the transformation of un, and what was that? That is always be a function of z. So you can write down that is capital U stands for a function of z. So then shifting to the right means z transform of un minus k is equal to z minus k u of z. And what is the k? K is a positive scalar. It has some positive value which is greater than 0. So we shall prove the result by the definition of Z transformation. So Z transformation of n minus k, that will be summation n is 0 to infinity un minus k into z raised to power minus n. You can put the value if n is uh, n will be there. What will be n? You can use the values for because we have shifting to the right. So you will start with n is a positive quantity. Sorry, k is a positive scalar which will lies between 0 and infinity. And we can say that the value of n can be taken as k. Suppose we start with n equal to k. N is equal to k, then k minus k will be 0, z bar minus k plus n equal to if we put n equal to k, this will be the value. And if we put n equal to k plus 1, this will be the value k plus 1 minus k. K cancel, that is a 1. And u raised to power minus k plus 1. If we put n equal to k plus 2, that will be u of 2. And u of 2, this one should be z. So u2 z raised to power minus of k plus 2, so on. Now this term can be written by taking z raised to power minus k out, and that will be summation n is 0 to infinity u of n z raised to power minus n. It is very simple. Z raised to power minus k, that is the function of z. This is the basic definition of a Z transformation. So shifting to the right, it is very easy to prove. Now shifting to the left, shifting to the left, shifting un to the left. And the statement is if Z transform of un is a function of Z, then Z transform of un plus k, that will be z power k, and that will be u of z minus u naught minus u1 z power minus 1 minus u2 z power minus 2, and so on. And there will be minus u k minus 1 z power minus of k minus 1. You can put this result. Z transform of un plus k, that will be summation n is 0 to infinity, and that will be un plus k that raised to power minus n. Now you can make the adjustment of the terms by taking z raised to power k is common. Summation n is 0 to infinity n plus k z raised to power minus of n plus k, because we need z raised to power k. This is the adjustment of the terms. So you can open the summation now. And before opening the summation, you can write down the terms like this. That will be summation n is 0 to infinity un z raised to power minus n minus summation n is 0 to k minus 1, and that will be un z raised to power minus n. See, just like that, just to see. What is this? I am trying to give you the explanation over here. Summation n 0 to infinity un z power minus n. Let us open this. That is u naught plus u1 z inverse plus u2 z power minus 2 plus so on. And the somewhat there will be k z raised to power minus k plus this term can be written like this. So this is the term we have, and k plus k plus 1 z raised to power minus of k plus 1 plus so on up to infinity. This is the term. And before uk z raised to power minus k, we also have the term here, that is uk minus 1 z raised to power. The term will be the term that is uk minus 1. The term will be minus of k minus 1. This will be the term, because before k we should have k minus 1, then previous term to this will be k minus 2. That will be for k minus 2. And if we subtract a few terms from here, and the terms will be u naught plus u1 z raised to power minus 1 plus u2 z raised to power minus 2 plus so on u k minus 1 z raised to power minus of k minus 1. So if we subtract these terms from this expression, so up to this term, and up to this term, all these terms will be cancelled. The remaining terms will be starting from this, and I am writing down those terms also that will be left with us. That is uk z power minus k plus uk plus 1 z power minus of k plus 1 plus so on up to infinity. And what will be this? That will be equal to that will be equal to u n plus k z raised to power minus of n plus k. So what is the summation? Summation will be from 0 to infinity. You just see, put the value. When you put a 0 here, you will get uk. This term will be there. When you put a 1, uk plus 1, then uk plus 2. So all these terms will be there, and this is the summation we have. So this is the explanation for this step. And what is this? That is z power k, and we can find out the z transformation. This is the standard function u of z, standard z transformation. It is given to us. So this is the standard z transformation which I am going to use here. No, the from the remaining terms we shall have, because all terms will be negative. For n equal to 0, this will be u naught. For n equal to 1, u1 z inverse, u2 z power minus 2, negative sign, and the last one will be u k minus 1, z raised to power minus of k minus 1. And close the bracket. And this is the term we require. You just see what we have. This is we want to go. Just observe this one. This is the required term, and hence the result. So we have been able to prove the shifting to the left also by using this. Now, shifting to the left can also be used for some standard remarks. The remark number 1 can be find out get a transform of un plus 1. When you put k is equal to 1, so use k equal to 1, you will get z raised to power 1 u of z minus 3. K equal to 1 mean this value will survive only, and the term will be left with us only u naught, because for k equal to 1 this value will be 0. So what will be left with us? That will be u naught. And for the second remark, you can find out the z transform of k equal to 2. That will be starting with the z square u of z minus u naught minus u1 z inverse up to this second term. So this will be similarly we can find out the Z transform of un plus 3. It means by using the property shifting to the left, we can find out the required Z transformation, whatever we require. So I conclude my lecture here. So I thank you to all of you. Thank you very much.